and it's new to me. I have been putting this together for the last month and a half thereabouts, and I honestly
Don't know what's in it.
I don't know what's in it.
That's the best kind, right?
And it's, the thing is, I have kept this very quiet. At this point, there are probably only 5 to 6 people on the planet that know, and 3 of them are being watched. So if they say, and 2 cats. They're probably streaming it right now.
Who's watching them?
That's the problem. But yeah, literally, this is been a hush-hush project. In that, and it's not anything hush-hush, it's just, I wanted to release it here and announce it here because I love Huntsville. And I think you guys would appreciate where I'm going. Now, you have to understand, I'm here to have fun. The Arduino is supposed to be fun. I am here to have fun. And please hold your questions to the end. Feel free to laugh your guts out if you wish. Throw tomatoes if you want. And do what?
They're too expensive now.
No, that's true too. I'm saved by the bell.
You gonna melt my boots?
Yeah. Yeah, just throw your shoes at me. Okay.
And
And
cost an arm and leg too.
there you go. Okay, I'm Glen Popiel, KW5GP. I write the ARRL Arduino books, and I also wrote their high-speed multimedia book, which is basically microwave and mesh networking. And I actually saw a couple of copies down at the JMR sales booth, which is now chat radio. And so there's a couple of signed books of that down there if you want them. But now let's go ahead and get into this. Like I say, I have not seen a lot of these slides, or don't remember seeing them because they were done at midnight. Space, the final frontier. These are the voyages of the Starship. Oh, crap. Wrong presentation. I think I fix this. That was for somebody else. Let's try this one more time. That's the wrong next generation. So who am I? I'm a network engineer and technology consultant for HTC Global Services in Memphis, Tennessee. I was first licensed as a ham back in 1973. We drove the Flintstone cars back then. I've got over 45 years in the computer and electronics field. Today I'm doing my networking and network engineering. I started out doing jet engine, remote data acquisition systems, telemetry and control on projects such as the SR-71, the F-14, 15, 16, and a whole host of others, including the Black Hawk helicopter. And I'm also author of ARRL's Arduino for Ham Radio book series, along with the occasional QST article and product review. I also show purebred cats, as Bill discussed here. I had the 15th best of all cats and the best Maine Coon female in the world in 1989, and it's a boy's world. And that included winning a Best in Show at Madison Square Garden, which at the time was the equivalent of the Westminster Dog Show, except it's for cats. My current pair are actually from that same genetic line. They're litter sisters, and they're also world champions. They double as editorial assistants, parts thieves. Let me tell you stories about the parts thefts. Project build supervisors and general nuisances. And typical of most editors, they have to work with my material. When they try to get on the editorial work, they got to sleep on it first. And while they have fancy registered names, they're nicknamed Godzilla and Rodan for obvious reasons. I think one of the reasons that I enjoy the Maine Coon is that they are basically Kit Kats. And I know you came here for the Arduino, but there's a purpose here. They come from the factory like this. You know, they're not fully assembled. All you have to do is add food and water, and you get this. Godzilla is 22 pounds, 3 feet 4 inches long. That's a few inches over a meter. So spread your arms and carry 22 pounds. So grab 2 10-pound sacks of potatoes. Her sister, I call the small one, has got a 5 foot 9 inch vertical leap. Stand up for a second. Yeah. Miss Alshine?
Oh, yeah.
She's the height of the lady in here, to give you an idea of how big this thing is. And I call her the little one. Okay, thank you. Sorry. And I told you all of that just so I could tell you this. Both are now world famous calendar girls, along with Dave Minster's cat, who's on the cover, of the 2022 ARRL calendar that features cats and shacks. Had to do that. And unfortunately, that's no longer available, so go beat up on Dave Minster and tell him you want him in there again. My latest book, More Arduino for Ham Radio, is also now available from ARRL. This book includes another group of completely new and unique ham radio related projects. Some of these projects are actually multiple projects within a project, so you see 10 projects in the book. No, it's more like 15 and 20 once you actually get into the projects. So there's a whole lot of new projects that you can build. So now, let's get into the Arduino part, which is why you're here. First, we need to set our Wayback Machine to 1988. How many of you remember Sherman and Peabody? I love them. I grew up with them. In 1988, I wrote a magazine article that predicted the future of computer technology. The article was titled, How Far Are We From HAL? And it was a discussion of HAL, the computer in Arthur C. Clarke's 2001: A Space Odyssey, the computer technology of 1988, and what technological advances would need to take place to create a computer similar to HAL. The article outlined the advancements that would be needed in processing power, speech, voice recognition, and vision technologies. It also covered the advances that would be required in storage. Remember, in 1988, PC memory was extremely limited, as was the disk, and it's expensive. Back then, 1 meg of memory cost $550. A 30 meg hard drive costs $450, and that's in 1988 dollars. One simple photo today would have filled up that entire hard drive. So we're talking megabytes, not gigabytes or terabytes. The article even predicted solid-state disk technology and the demise of magnetic tape. 1988, I thought I did pretty good. All in all, mainly a result of some very lucky guesswork and my lucky magic 8-ball. That article really did prove to be quite prophetic. In fact, the lowly Arduino can and is doing a lot of things that was predicted in that article today. And it's doing it with very inexpensive components. We don't even think twice about such things as Alexa, the Ring doorbell, and the other advanced technologies that we use today. For reference, the control data supercomputers used by NASA back in the Apollo missions had a 60-bit CPU running at 10 megahertz with 982K of RAM. And that was magnetic core memory. In many respects, the Uno is equally as powerful as those multi-million-dollar room-filling monsters. And it uses far less power than the 30 kilowatts each that those 6600s used. I often spoke of the computer world eventually unifying under a single programming language or programming environment that would work with whatever hardware vendor you chose. Hello, Arduino. While we're not quite there, and probably never will be 100%, we're really close. The Arduino comes very close to proving that one language to rule them all to be quite prophetic as well. I don't have enough hands. When are we going to evolve to have 3 hands, 4 hands? So let's dig out my trusty old magic 8-ball that I used to write that article. We're going to shake it up and see what it can tell us. But oh, by the way, did you know that these things kind of get a little volatile with the fluid inside after they've been sitting up for a number of years? Shaking this one up might not be a good idea. So instead, it's time for an upgrade. Did you know it's actually fairly easy to open up a magic 8-ball? You can remove the inside. The key component is a 20-sided die that's inside a liquid-filled cylinder. And all you gotta do is cut around the edge of the seam. So it cleans out pretty easy. So why don't we take an Arduino Nano, a 128 by 32 pixel organic LED, and put it inside. Then a customized sketch based on the Instructables website's Magic 8-Ball with an attitude can then be loaded on the Nano. And as you can see, it does indeed have an attitude. Now, before we rattle this new genie's cage, let's look back on where we've come from. The Arduino has definitely come a long way since 2005. There are now all manner of Arduinos and Arduino variants, in addition to the original Arduino Uno and Nano that I have traditionally used to build some really cool projects. Most of these new microcontrollers are supported in the Arduino IDE and are every bit as easy to program as the original Arduino Uno. The Arduino Uno and Nano both use the ATmega 328 chip, which gives us an 8-bit, 16 megahertz CPU, 32K of flash, 2K of RAM, 1K of double EEPROM. It's got 14 digital I/O pins, and 6 of those can do pulse width modulation. It's got 6 analog inputs, and the Nano actually has 8 that go to a 10-bit analog to digital converter. These analog pins can also be used for digital I/O if you need additional digital I/O pins. It's powered by 7 to 20 volts DC with a regulator on the board or via the onboard USB port. It also has an SPI and an I2C bus on the board. But I also found some new ones that we really need to include in this discussion. You've got the Pico, and this is not to be confused with the Raspberry Pi Pico. It is the size of a dime. Then you've got the Mini Uno, which is the size of a quarter. And they both use the ATmega 328, but they have a smaller footprint. The Mini Mega at the bottom, you gentlemen were talking earlier, the ATmega 2560, it is the 2560, but it's 3/4 the size of an Uno. But now it's time to take a giant leap. You've always heard me say that when it comes to the Arduino that you're only limited by your imagination. I still feel that nothing can be more true than that simple little statement. For my first 3 Arduino books, I focused mainly on the Uno and Nano, and primarily because of their low cost, simplicity, and ease of use. But there's one thing that you don't know, and that I really wouldn't talk about. I was embarrassed. And I do need to warn you from this point forward, please make sure that your seatbelt and shoulder restraint are firmly fastened. Make sure your tray table is in the full and upright position, because we're about to crank things up to about an 11 or 12. And if you don't have a seatbelt and restraint, raise your hand. We will see that somebody holds you down. I was on a quest. I've been constantly looking for the perfect next level Arduino processor board. To create advanced projects, I knew that I'd need more CPU horsepower, more memory, everything than the Uno and Nano could provide. I needed more I/O, a higher resolution A to D, more flash memory, more RAM. I needed the kitchen sink. And it had to be inexpensive. In other words, I seek the grail. During my quest, I found Arduino compatible boards that came close to what I was looking for, but were not quite it. The STM32 family that includes the blue pill is inexpensive, it's fast, it integrates in the Arduino IDE, and meets much of the criteria. But the various versions of the board may or may not come with the Arduino bootloader pre-installed. And it uses a slightly different sketch upload procedure, so you might have to go through some extra steps to bring it fully into the Arduino IDE environment. The ESP32 and 8266 are also close, and they come with Wi-Fi, Bluetooth, and other features, and they're inexpensive. But again, they just missed triggering my Grail detector, which, of course, it's Arduino powered. The STM32 is a family of microcontrollers, there's where memory stops, based on the ARM Cortex-M series of CPUs. The blue pill version has a 72 megahertz compared to the 16 of the Uno. Cortex-M3. It's got 64K of flash, 20K of RAM. It's got 32 digital I/O pins. 12 of those are capable of pulse width modulation. You've got 14 analog input pins, 3 serial UART pins, 2 SPI buses, 2 I2C buses, and it's a whopping $3. But depending on where you get it, the board may or may not have the Arduino bootloader pre-installed, and this requires those extra steps to fully be used with the Arduino IDE. Not the Grail. The Expressive ESP32 microcontroller is an updated version of the ESP8266, and it offers Wi-Fi along with both Bluetooth and Bluetooth BLE. You can get it in available 10 silica 32-bit CPU, and you can get them in 160 to 240 megahertz, 4 to 16 mega flash, 38 to 77 I/O pins. If you've got a project that needs 77 I/O pins, talk to me about it. We can make millions of dollars with whatever it is. You've got up to 18 12-bit A to D pins. Same goes. Who needs 18? 2 8-bit D to A. This is a first. I like having the digital to analog capability. 10 capacitive touch switch sensors, 4 SPI channels, 2 I2C channels, 3 serial UARTs, up to 8 channels of infrared remote control, up to 16 channels of pulse width modulation pins. It's even got an integrated Hall effect sensor on the chip, and it runs on 3.3 volts. And it costs about $3.
Wow.
It's a good option, especially with the integrated Bluetooth and Wi-Fi. And I'll probably have some ESP32 projects in a future book, but it's not the Grail. Here are some other boards that came close. Early on, the 80 megahertz 32-bit microchip UC32, formerly the Uno 32, was a contender. But at over $50, it's still too expensive to want to work with. I'm cheap. The Teensy series of Arduinos comes very close, with the 4.1 having a 600 megahertz 32-bit ARM Cortex-M7 processor, 8 mega flash, 1 mega RAM, and 4K of double EEPROM. It has 55 digital I/O pins, 18 analog inputs, and a selectable A to D resolution of 10 or 12 bits, and a ton of other features. The 4.1 is so close to what I was seeking that there will most likely be some teensy projects in one of my future books. But again, at $32, it's a bit on the expensive side. So the quest continued, but I do have to admit, I began to lose faith. Would I ever find what I was looking for? About a year or so ago, I was approached by ARRL to write a book on a ham radio related Python projects using a specific microcontroller board. I declined at the time as I felt that there was more for me to do with the Arduino, and still it warranted a second look. On the hardware side, this new microcontroller fit the bill. It has a dual core 133 megahertz ARM Cortex-M0 Plus, 2 mega flash, 256K of RAM, 26 digital I/O pins, and 3 12-bit analog to digital inputs. And I bet you there's about a half dozen people in the room that know where I'm going right now. Somebody blew my mind when I did a forum a couple weeks ago, and they're like, yeah, but I can't tell you.
58 minutes.
Are we ready?
Yeah.
Okay. Has 2 I2C buses, 2 UARTs, and 16 of those pins can do pulse width modulation. It even has 8 user-programmable PIO state machines so that you can create your own custom hardware peripheral support. To add more icing to this cake, it has an on-chip real-time clock and temperature sensor, and its onboard MicroPython supports 2 simultaneous processing threads, meaning that it can run 2 separate programs at the same time. But I didn't want to do Python, and the darn thing ran Python. Or did it? At this point, I was still not convinced that I had found the Grail. I did not want to learn Python. I did not care that the board cost a mere $4 if it meant that I had to learn Python. Period. End of story. I'm not interested. Cue the next news feed, please. Further research into this new microcontroller caused me to take a second look at Python. To this point, my impression on Python had been that it was a scripting language for PCs. Still not interested. Can't get excited about it. But it turns out that that initial impression was not quite correct. Further investigation revealed that Python on microcontrollers is becoming more and more like the basic programming language we had back in the 1980s. It's simple, it's easy to learn, and it's easy to use. But doggone it, it was still Python. And it didn't integrate into the Arduino IDE, so why are we here talking about this thing? So we'd have to relearn everything that we knew. This cannot be the Grail. Search continues. Next news feed. Detailed the operation of this microcontroller and revealed that it had features that allowed the user to change the programming language from the official MicroPython distribution to other language, such as SparkFun CircuitPython and a C++ compiler. The boot image could be changed with a simple press of the boot select button on the board. Still, there was no Arduino support. This is not the Grail we're looking for. Let's clap those coconuts together and ride on. But wait, there's more. The final piece of this message finally got through loud and clear. Earl Philhauer has created an unofficial translation of the Arduino ecosystem to the UF2 bootloader image that this new microcontroller uses, and it's available for free on GitHub. Then there came the announcement of an official Arduino bootload image for this new microcontroller. This means that this little $4 board now meets all of the conditions to be my holy grail of the Arduino world. But this new microcontroller comes from the most unlikely source. Could we have been looking in the wrong place this entire time? Let me introduce you to the Raspberry Pi Pico. Indeed, there's some sorcery in this thing. Raspberry Pi. Well, not quite. It's the Raspberry Pi Pico. It's based on the RP2040 microcontroller family from, yes, the Raspberry Pi folks. Let's take a closer look. I still think this thing is fake. Can't be the real Grail. Did someone spike our punch? Actually, on my way home from St. Louis in January, I picked up two, so they are real. It has a dual core, 133 megahertz on Cortex M0 Plus, 2 mega flash, 256K RAM, 26 digital I/O pins, 16 can do pulse width modulation, 3 12-bit digital, analog to digital inputs, 2 SPI buses, 2 I2C buses, 2 serial UARTs. It even has USB host capability, 8 PIO state machines. It's got an accurate on-chip real-time clock and a temperature sensor. And it costs $4. And it's readily available today in spite of the chip shortage. I bought 2 of them at retail at Micro Center in St. Louis in January for $4 each. So in my opinion, this does have to be the Grail. It has all the horsepower, memory, I/O, and a ton of other features to build some really nice Arduino projects. Think SDR. With the Arduino bootload image, it can seamlessly integrate into the Arduino ecosystem. Most of the existing Arduino modules and libraries are directly supported. For me, personally, this is the low-cost microcontroller I've been looking for in order to take my Arduino projects to the next level. And yet, you retain the ease and simplicity of the Arduino development environment. No Python. This quest has finally somehow managed to reach a happy ending. The future of Arduino projects for me looks very bright for now. But does anybody know what those dark clouds off in the distance just might mean? But wait, before we go deal with that, there are several new versions of the Pi Pico that have just been released, and they're still in the $4 to $6 range. The Pi Pico W now includes an onboard Wi-Fi chip. The chip supports 802.11b, G, and N modes. And while the chip itself supports Bluetooth Classic and Bluetooth BLE, the initial release of the Pico W will only support the 2.4 gig Wi-Fi modes. The other 2 versions are the H and the WH, and these are simply the same first 2 boards with the headers pre-installed on the boards. But there's even more. Other vendors are now jumping on this bandwagon and creating boards based on the RP2040. The WeAct RP20 is a Pico style board with 16 mega flash instead of the Pico standard 2. If you can't do it in 16 megs, you're going to need a bigger boat. And it's only $8 from AliExpress. The RP2040 Zero board is based on the RP2040, but with a smaller footprint and fewer I/O pins, again, close to the size of a dime, and it's $6 from AliExpress. And these are readily available. I got them about 3 weeks from China. And there's even more. The LilyGo T Pico C3, there's a mouthful, has both the Raspberry Pi Pico 2040 and an ESP32 C3 on a single board. And they threw in a 125 by 240 pixel 1.14 inch color TFT display. All on this one little itty bitty board. The ESP32 C3 is a single core 32-bit 160 megahertz CPU with 400K of RAM, 384K of flash, with 22 programmable I/O pins, onboard Wi-Fi and Bluetooth, and has an onboard JST connector so you can hook up a LiPo battery. Switching between the Pico and the ESP32 is done simply by turning the USB-C programming cable over. An onboard LED, isn't that neat?
Yes.
An onboard LED will light green or blue to indicate which processor is active. And this is only $13. That is, everything's right there on one little board. But there's still more. The LilyGo T-Display RP2040 is a 2040 board with that same display, and it includes an onboard JST. It just doesn't have the STM32, and it's $13. Finally, the RP2040 development board has an onboard 70 by 40 pixel 0.42 inch liquid crystal display. It also features a KW5GP I2C, too many initials connector. And it's $12 from Banggood. So as you can see, there is already an ever-broadening list of choices for the Pico type board. So you're not limited just to Raspberry Pi's distribution. And let's just throw one or two more in for good measure. The Pimeroni Tufty 2040 has a built-in 2.4 inch color display. It's designed to be a color LCD badge. Has 5 push-button switches and a JST connector for external power. Runs on 3 AAAs or a LiPo battery. It's $28, but unfortunately the shipping cost is about the same coming from Europe, so a little bit high for right now. Hopefully they'll get a stateside distributor. The Pimeroni Badger 2040 uses the e-ink display, and it's $16.50, but again, the shipping cost is still just a hair high. So where does this leave me? I'm currently working on a Best of Arduino due to be turned into ARRL in December. This is the best projects in my mind from the first 3 books. So if you've got a favorite that you would like to see included in this book, now is the time to either send me an email or let me know, and I will see if there's room to stick it in that book because I'm still forming the book. It's about half written, but there's room. The projects will be upgraded with modern components such as color displays, new text-to-speech modules, and much, much more. And of course, the sketches themselves will be updated and new features are going to be added. Now, remember those dark clouds we talked about? Naturally, we're going to have a cliffhanger if I'm going to get you guys back here next year, right? So we got to leave room for a sequel. Everyone knows that real quests for knowledge are never ending, and it's true in this instance as well. Again, as with any quest, this journey has changed and enlightened me. Part of the reason I'm a ham, work with microcontrollers, write the books, present these fun forums, and enjoy all the wonderful aspects of the amateur radio community is the personal challenge to research, discover, and continue to learn new and exciting things. This quest has indeed changed me. For lack of better words, I strayed too far into the light while on this quest. My eyes have been opened to new and wonderfully exciting things, and I can't unsee what I have seen. I can't unlearn what I've learned, and I'm not sure I really want to. Nothing ever stays the same. In the world of ham radio, kit, and project building, electronics and technology in general, nothing ever stays the same. Things are constantly changing. So here we are, standing on the edge of the future, looking at our magic 8-ball again, and we're not going to shake that thing up. Do we stay here, safe and secure in the Arduino world? Or do we continue forward, walking on that razor's edge into the unknown? Now, I've already asked my magic 8-ball, and it knows this answer. So let's shake that one again, the new one, and see what it has to say. Yeah, I do love this new magic 8-ball. Why not have the best of both worlds? It's not an exclusive environment here. As I've said, everything is constantly changing around us. This is also true in the microcontroller world. We'll always have the Arduino, but it seems the microcontroller world is moving towards Python-based microcontrollers. And why not? Python's been called the basic of the new millennium. It's easy to learn, and it's easy to use. And a cool thing about Python is that you can run it both interpretively and compiled. This drastically speeds up your creative process and potentially saves you a ton of time waiting for your programs to compile, upload, oops, I had a bug, compile, upload again, doggone it, have a typo, upload again and again and again. So with Python and the interpretive, you can actually test it right there. So is this the end of Arduino? Absolutely not. Do not even think it. But it does say that we have more options than ever in regards to our microcontroller projects. Microcontrollers such as the Raspberry Pi Pico are just the leading edge of a whole new generation of microcontrollers. The multiple programming language capability of the Pico adds even more choices to our microcontroller arsenal. Now you can design and build with a single hardware platform and choose the programming language that's best for your project at hand. But for me, the thought on using Python on the computer, yeah, I have to admit, it got me. It's kind of seductive. See, that's Python calling right now. The Raspberry Pi Pico was designed around MicroPython and the ability to switch to a new programming environment later on down the road. It gives us a very flexible and long-lived development environment. The Arduino world is just now beginning to embrace the real-time multi-threading and multitasking capabilities with such tools as the free RTOS, which is free real-time operating system, and this requires a higher-end Arduino. It won't run on the Uno and Nano. It needs something 70 meg and higher. The Python is inherently multi-threaded, and in the case of the Pico, you can natively run 2 programs simultaneously, 1 in each core. Which leads me to say, yet again, there are no limits. When it comes to the world of microcontrollers, you really are only limited by your imagination. As long as it doesn't violate the laws of physics. Now, if it does appear to violate the laws of physics, before you totally give up, try a bigger hammer, more voltage, borrow my other magic 8-ball, something along that line to take care of it. But now for me, have I chosen wisely? ARRL and I now have plans for at least 2 books beyond the Best of Arduino series. Both of those are going to focus on the Raspberry Pi Pico. The first book will use Pico and probably a few other microcontrollers using the Arduino programming language, the IDE, and the ecosystem. So it will be another Arduino book. The second book is going to be focused on using the Raspberry Pi Pico and that word I can't say, Python. And I can't talk about this yet, there are even more books in the work. We are, as of this morning, we're actually now at a total of 7 books, as fast as they can get turned out. I'm a 1 year a book kind of guy, so this is going to get fun. So yeah, it's looking like that. We don't have the exact number because, quite honestly, we're still negotiating the price of my soul. And does anybody have a Kelly Blue book that might list the cost of a kind of old soul? Just got a few dents and dings, good paint, it runs good, sort of. Had the engine rebuilt a few years ago. But your journey is just beginning. You are builders, thinkers, creators, and inventors. You're a perfect match for the Arduino and the microcontroller world. Now, imagine the projects that you can build now that you know this next level. You can build them with the Arduino and other microcontrollers. And then go make them happen. It's not that hard, it really isn't. And it's cheap. So with that, I am done. Any questions, comments? Yes, sir.
I thought in your requirements for the Grail, I thought you had listed analog output pins, but I did not see analog output pins listed in the Pi Pico.
That's correct. Analog output was not a requirement.
Oh,
I needed input. And if I need output, there are external chips that run on I2C that you can use and
and when you
interface.
have pulse width, what is your recommendation to get a very specific analog output voltage converted? Is it like a digital potentiometer?
Popiel.
When you use pulse width, I'm generally not looking to generate a particular voltage. That's where you would need the D to A. I'm looking to generate a varying pulse,
A signal?
a digital pulse to control motors, servos, and things that are pulse.
It's all right, I haven't found a good answer anywhere
Yeah,
for getting this very specific voltage to come out of that.
for a very specific voltage, the only way that I know of is to use a digital to analog converter.
You could probably use a pi network that was controlled by.
A resistive
Yeah.
D to A, yeah. And that's actually listed in my first or second book. Anybody else? Yes, sir.
Could you, you mentioned RTOS, is that something that's compatible with the Python development environment?
I don't know. At this point, RTOS was designed for the Arduino, or the version that I'm familiar with. But it's Python. I am sure that they're going to have something similar right now, because Python was designed to be multi-threaded. So I think you're going to see a lot of that moving forward.
You teased software to SDR in one of your statements. Do you think it would be possible to create a smart receive antenna that had the ability to digitize the signal at the antenna?
Yeah. The question here is, can you digitize the received signal similar to an SDR and then transmit that digital down the line? And the answer would be yes. You can get a fast enough A to D and do the slicing right there at the antenna end, and then feed it down over Ethernet.
Interface it using the I2C as a bus?
Well, your interface, you've got the question was how would you interface this in the I2C bus? You can do it on I2C, but you also have Wi-Fi, the LoRa modes that work with the industrial, the ISM band stuff, Adafruit's Feather line, or you could go with Ethernet. And you could use any of those communications. I personally would go with Wi-Fi. You can also use Bluetooth. Anybody else? Or y'all just looking at me like I've gone crazy and over the deep end?
I've done that for years.
Yeah, yes, sir.
Do you think, you'd be the perfect person to ask, obviously.
I'm not perfect in anything.
You'll be perfect at this, I'm predicting. As we move, maybe we move away from the Arduino trademark name, we get into these things like Pi Pico and some of the others that you listed, and embedded Python. We move into that, and yet people still say, can you hand me a Kleenex?
Yes.
Does Arduino become the equivalent of a Kleenex?
I would say it's already become that way.
Yeah.
Because I just call it an Arduino, and it's an STM, and actually the Nano is not an official Arduino board.
Yeah.
And so, yeah, I think it's just all been covered that if it works with the IDE, technically it's an Arduino. And fortunately, because it's open source, they're not really enforcing that trademark per se. They are enforcing the Arduino product, but they're not really enforcing, if it works with Arduino, it's close enough, call it an Arduino. Kind of like Kleenex, the cat's already out of the bag, can't put it back. Yes, Bill?
My balloon tracker uses the Atmel 328P, and I program it and test it all in their Arduino environment.
Yeah.
So I guess you could call it an Arduino with flaws.
Yeah. Yeah, it's an Atmel AT328, which is the Uno, Nano, and the whole 9 yards. So again, where do you draw that generic line? And since you're programming it with the Arduino environment, call it an Arduino and be done with it. Let's not argue over the semantics of who's what, just use it. Yes, sir.
Can you give an overview of development tool options, or is there only a single one?
For the Arduino,
Yes.
your number one tool, there are a couple other tools, but the Arduino IDE has been evolving through the years, and it's really the place to go. Because you can integrate all of the new boards just with the library manager, you can say, go add this new board, and it will add the board as a drop-down menu in the IDE. So I would say the IDE is your one-stop shop for the Arduino.
Does it support Pico?
It will in that Arduino bootloader. I do not believe it will in the Python. For that, you've got to go the recommended Python route, which is still relatively new to me. Yes, Bill?
How hard is it to put the Arduino bootloader on the Pico Raspberry Pi?
No, my understanding, how hard is it to put the Arduino image on the Pico? And basically, you hold the boot select button down, and it will go and pull down that bootload image off of it's basically a little mini computer. It reaches out and finds a shared drive, kind of like your USB becomes a shared drive when you hook it up to a PC, and it will find that image and pull it down. So you hold the boot select button, it pulls the image down. That's all you do.
So you don't have to add a bootloader to it?
No, it's got the bootloader. It just adds this as a bootload image. So then when you power up the board, now it's natively Arduino, and it will talk to the IDE just as if it was a standard Arduino board. Any other questions? Oh, come on. Did I totally stun you or bore you? How many of you are sleeping here? Yes, sir.
I'm into rocketry, and we need altimeters so we can deploy parachutes at altitude, which I think somehow they could be the balloons.
Yeah.
To do that, you have to have a voltage, right, to detonate the charge. Arduino is used for that. A lot of people have done that. I've read about it, but I don't know anything about how to do it. Is
Now,
that stuff-
what kind of weight are you talking about on your payloads?
6 pounds.
Oh, you've got plenty of room for power then. Yeah, I mean, you can easily do it with an Arduino. Think transistor driver or relay. Probably want a relay or something a little more fail-proof, because you don't want the thing exploding on the ground. But yeah, you can easily do it with a little 5-volt relay or what have you.
Along with that telemetry.
Yeah.
Radio telemetry.
Yeah, well, video telemetry, the Arduino itself doesn't do video, but it can control the starting and stopping of a video recorder. You're probably gonna, if you're gonna move into the video side, you're probably gonna want something like a Raspberry Pi itself that has the video capability, since it's basically a little Linux computer. Anybody else? Yes, sir.
If I want to power my Arduino or Raspberry Pi solarly, I would imagine, is there any easy or off-the-shelf solar cell battery that would be sized for something as small as that?
Bill Brown, who's doing the high altitude balloon forum after me, he would be the one to talk to about low power, because all of these balloon trackers are powered by solar cells.
Oh, okay.
And
That brings up a question: what is the average current drain on this Pi Pico?
I meant to look that
And
up.
how low can you get the current drain to go?
I have been told it's very low, but I have not actually seen the specs. That was one thing that I kept overlooking, and every time I'd start to do that, I'd get called away on something, so I'd never really looked that up, but it's very low, and it is been touted as a low power solution. So I'm gonna say very low.
If you want to go low power, you probably want the version that doesn't have Wi-Fi on it.
Right.
That would draw.
Well, that's a separate Wi-Fi chip, so really what you want is the RP2040 chip and build from there. Because the actual memory is an external SPI bus memory. So it's however you want to roll it there.
Or at least the ability, since I only want to operate it a fraction of the time, to be remotely be able to turn it on and off.
I believe it has sleep mode built in on the chip, yes. And I remember seeing this, it's just, I was trying to cram so much into what I had, but I just overlooked 2 and 3 things. Like I say, this is a brand new presentation. I was actually reading it because I don't remember writing it. Yeah.
It's cool. I'm so glad to walk through this because I've looked at all these things and I'm like, this is taking so much of my brain.
Right, that was the exact same thing, and then I hit the Pi Pico, and again, when AWL came to me and said, we want a Pico Python book, and I'm like, no, it's not where I want to be, no. And I kept getting subsequent news feeds and pieces, and I'm like, maybe I said no too soon.
Yeah, Saul, it's hard.
Yeah, so I went crawling back to ARRL, and I said, you were right, I was wrong.
Hey Glenn, what, is there on the Pi Pico, is there a camera interface to the Arduino cam? Or is that any way of interfacing the two?
How does the Arduino cam interface?
I know on some of the bigger Raspberry Pis, there's a special connector.
Okay, no, it doesn't have any video capability like that. If there's an Arduino library for a camera, then yes. Like an SPI type camera, yes. But outright, no. You know, think of it as an Uno on steroids. It's the best way to look at it. I mean, when I saw the 133 meg, I was like, cool. Then I saw the dual core, and I was like, cooler. And then I saw that with the Python, you could run 2 simultaneous programs, and I'm like, whoa. Now we're getting into real-time operating system stuff. And when I saw the 33, whatever the megahertz, my brain just froze. When I saw the speed on that, I was just like, this is exactly what I have been looking for. Now we're talking SDRs and all of that cool higher-end stuff. Yeah, Bill?
Is there a way to run an Arduino program and a Python at the same time?
No, because the bootloader is separate. You have to bootload the image into Flash. So, no. Now, the question I have is, what about that one that has the STM32 on the flip side? How would, you know, it shares stuff, so can you actually do both at the same time? That's going to be an interesting question. I'm going to say no because it shares too many resources and clock cycles and stuff. But you never know. And that could be the next step down the road.
It might be multiplexed in there.
Yeah. I just like the idea of, oh, turn the USB cable over and I got a different processor.
Memory management.
And I think we're going to start seeing a lot of that coming down the road. The hardware is becoming a commodity now, really. And the software is this unified environment. It's the same thing on the Python side. They're standardizing on the MicroPython, the Circuit Python. So you've got that one language to rule them all aspect again. You use their development environment. I can't remember the name of it right now, but it's, you know, a single Python, but it's interpreted. So you can literally, you know, but you just use their editor. And so the Python side of it really is appealing, but I still love the Arduino because, you know, and this is why there's going to be a transition book on the Arduino on the Pico, because there's just so many cool things you can do with dual 133 megahertz processors that you can't do. Yeah.
Your book?
Another question. Can
I've got to sell books.
Can you throttle the processor speed down to conserve
That I
power?
don't know.
I know you can do that on the teensy.
Yeah, I'm not sure you can do that with the.
Goes back to your
Pico.
current drug.
Yeah, I have not seen it, but I wasn't looking for it. Anybody else? Well, thank you. Yes, sir.
I don't know if this is where that camera question was going, but my house is, I have a bunch of the Pi interface camera. I find the Pi Zero the easiest thing.
Yeah.
That has that interface and
Right.
requires very little power, and then you can control storage, put your video feed up to NAS.
Right.
And, you know,
And it's cheap.
it's cheap.
Yeah,
Well,
I've got one.
Pi Zeros aren't cheap right now, but yeah.
Yeah.
A little hard to find right now.
I got one. What's it worth?
It's bidding more.
I actually built one as using the Pico or the Pi W as a gas pump skimmer detector. Because I had my gas pump or my credit card get skimmed at a gas pump, and what they are doing, they are opening up the pump, sticking their board in between, and ribbon connectors all match, and then they're transmitting the credit card data off on Bluetooth. And there was actually, Make Magazine had a Raspberry Pi Pico version, not Pico,
Zero.
Zero version, and I said no, and I made an Arduino version. And it worked. It also picked up every open Bluetooth signal on the highway. I could have fun with your GPS. I could send you out into that next cornfield and you would never know it. Yes, sir. Anybody else? Okay, thank you so much. Hope you enjoyed it. And next up is going to be Bill Brown and his high altitude balloons using an Arduino. No Python.